Hello, myself Ravindra Chavan, Assistant Professor, Department of Electronics Engineering, Walchand Institute of Technology, Solapur. So, today in this session, we will discuss the programming for the 8051 microcontroller. So, the first program we will discuss to count the number of ones in a given byte, which is stored at suppose address 30, and whatever the result, that is the count of one, that we will store at address 31. As these are the 8-bit addresses, that means these addresses are located in the internal data memory. So, very first step is the initialize the required counters. Now, for this program, we are requiring the two counters. One is to store the result, that is the count of ones, and second one is the to check how many times the loop has been iterated. So after initializing the counter, whatever the given input number, which is at address 30, you transfer this into the accumulator, that is nothing but the register A. Then rotate the content of the accumulator through carry bit. Now here we can rotate either in left or in right. So we can either start with the MSB bit or LSB. After rotating, check the status of the carry bit. If carry bit is 1, increment the result counter. Else means if carry bit is not set, then don't increment the counter. Okay, so if carry bit is 1, increment the result counter, else go to the step number 2. Again take the next bit into the carry bit, again check whether the carry is 1 or not. If carry is 1, increment the result counter. Now repeat these steps 3 and 4 8 times. Why 8 times? Because our input number is a byte which contains the 8 bits. So you check all the 8 bits for 1. And finally, after checking all the 8 bits of a given number, you store the result. Whatever the register we are used to store the result, you store the number of ones, that is a count of 1 at address 31. Now the program is shown here to find the count of 1. So we are starting with the initialization of counter. So first R2 register is here used to store the result, that is the count of 1. Then the R3 register is used to check how many bits are tested. Then take the number into the accumulator. The number is stored at address 30 that we had taken into the accumulator. Then rotate left through carry the given number. Okay, if we are rotating here left, that means the MSB goes into the carry bit and D6 moves to the D7 and so on. Now after rotating the given number, you check whether the carry is set or not. So jump if no carry to the address next. That means whatever the R2 register we are used to count the number of ones, don't increment that register. Okay, if carry is generated, then this condition is false and the INC R2 instruction will get execute, means R2 will be incremented by 1. Now do this again. So for that, decrement the R3 register. If it is not equal to 0, again go to the instruction whose address is again. So again the next bit will come into the carry bit. Then again it will be checked whether it is carry or not. If carry bit is set, then the R2 will be incremented. If carry bit is not set, then this INC R2 instruction will be skipped and the program control will go to the address next. So after checking all the 8 bits, whatever the result we are getting in the register R2, that we had taken in the accumulator, and from accumulator that value, that is the result, we had stored at address 31. Now the next program we will discuss to count the positive number from an array of a given 5 bytes which are stored from address 30, and store the count, that is the number of positive numbers at the next consecutive address. Okay. So before going to the program, if we are saying the signed numbers, then how to check whether the given number is a positive number or a negative number? So if we are using the 8 bit to define the number, signed number, then the MSB bit is reserved for the sign, and lower 7 bits are actually deciding the value of that particular number. If MSB is 0, that means the number is positive. If the MSB bit is 1, that means the number is negative. So MSB bit we have to check. So again, first step, initialize the counters, whatever required, the loop counter, result counter, memory pointer. Again here we are requiring because the 5 numbers are stored from address 30. Then next step, you take the first number into the accumulator. Now here we have to rotate the number left through carry because we are interested to check the MSB bit. Okay, so rotate the first number which is already taken in the register A left through carry. Now check the status of carry bit. If carry bit is 0, increment the count of positive number. Else go to step 3. Then move to the next number by incrementing the memory pointer. Now repeat the steps 2 to 5 for all the given numbers in a array. So check all the 5 numbers and store the result, that is the count of positive number at the next consecutive address. Now first, here the R3 register is used to store the count of positive number, that is nothing but the result. Then the R2 register is used as a loop counter, and which is initialized with the value 5 because we are considering the 5 elements in a given array. Then the R0 we are initializing with the address 30, which we are using as a memory pointer. Then take the first number into the accumulator. Then rotate left through carry the first number, so MSB bit will go into the carry bit. Then check whether the carry bit is set or not. If carry bit is set, don't increment the register. That is our result, which we are using as a register R3. Okay, so if carry is not generated, this condition will false and then R3 will be incremented. Then go to the next number by incrementing the memory pointer. Here decrement the loop counter, check whether it is 0 or not. If it is not 0, again take the next number into the accumulator and do the same steps. And when all the numbers has been tested, whatever the result we are getting in the register R3, first take into the accumulator, and from accumulator you store at the memory. Now from this program you take these three as an exercise. First, write a program to count the number of zeros in a byte. So you just modify the first program, then write a program to count the negative number, and then write a program to count the odd number. Now how will you decide whether the given number is a even or a odd? So for that it is required to check the least significant bit of a given number. If that number is 0, means the number is positive. If the LSB bit is 1, that means the number is a odd number. So references 8051 Embedded C Programming by Mazide and Mazidi, and Microcontrollers by Ajay Deshmukh. Thank you.